you're supposed to learn about two things. You learned about which direction is shading, above or below, and you should have learned about the line type. Is it going to be solid or dashed? So if I have just greater than, what does greater than mean for shading? Guys, it kind of, let's make, I'm not being funny. Let's make a common sense connection here. If I have greater than, and I'm asking you if I'm shading above or below, what connection is that going to be? If I'm going greater than, am I going to shade below the line? Does greater than and below make sense to go together? Okay, so if I'm doing greater than, then that means I'm going to shade above the line. So if we're going to do greater than, this is going to be above the line. But this does not have an equal to. So I'm not going to have a solid line when I graph it. This is going to be above and dashed. Okay? Now, what if I have greater than or equal to?
It's going to be all the way through, not dashed.
Okay, so it's still going to be shading above the line, but this time it's going to be a solid line. That is the difference between those two. They're both shaded above because they're both greater than. But if it's just greater than, it's dashed. If it's greater than or equal to, then it is going to be solid. Okay? So what about less than? All right, so let's make those connections. If I have less than, what type of shading am I going to do? What direction?
Below.
So we're going to shade below the line. So if I'm shading above the line, below the line, but there's no equal to, then this one's going to be dashed. And then if I have less than or equal to, this is going to be below and solid. Okay, these are things that you need to know. These are the ways that you're going to graph. Now, I'm going to start off with just a slope-intercept problem. So if I have y is less than negative 3 over 5x minus 5, or excuse me, minus 1. So we need to graph this line. What's the first thing I'm going to do to graph this line?
Find your y-intercept.
Okay, what is my y-intercept?
-1.
All right, so I'm going to go to -1, and I'm going to plot that y-intercept at -1. Okay, so my b is 1 here, or excuse me, -1. Now, from my y-intercept, what am I going to do?
The slope.
All right, so what is my slope?
-3 over 5.
All right, so I like to put the negative in the numerator. So if I have my negative in the numerator, we need to do rise over run. So if I have a -3, what direction is that telling me to go?
Go down.
Okay, so remember it's rise over run, up or down, then left or right. So we're going to go down 3, right 5. All right, so from that point, I'm going to go down 3, 1, 2, 3, and right 5. And there's my new point. Okay? Now, this greater than, or excuse me, this less than right here. If it's less than, what does that mean for us? What type of shading?
Solid. You said less than.
If it's less than, what type of shading? Okay, so the line is going to be dashed, yes. But the shading is going to be below, okay? So we are going to make a dashed line here. Okay. And then the question is, what does below mean? Well, the way that I handle this, and everybody look up here, whether you've watched this video or not, okay? When I do shading, depending on how vertical your line is, sometimes below doesn't always look below. It kind of looks to the side, okay? So what I do is I go to my line and I go to the ends and I draw arrows pointing downward because I want to shade below. So that tells me that I'm going to shade this area where my arrows are pointing. If I were going to shade above, I'd go to the line and I point arrows up and then I'd shade above that. So for this one, you can kind of see it better because it's not as steep, but once that line gets more vertical, sometimes it gets a little bit hard to see the above or below, okay? Now, can anybody tell me what this means? Why did we just shade that? What does the shading mean?
Any of them, like, any point in their shading can fit into their problem.
So the shading means that I don't have just one solution. I have multiple solutions. Any point in the shaded region will be true for that statement. Now, what do I mean by that? So I'm going to pick a point. All right, let's see. I'm going to pick the point, let's do 0, -4. Okay? So for 0, -4, this is my x, this is my y. So I'm going to plug in -4. Is that less than -3/5 times 0 minus 1? So I'm plugging those values in to see if it's true. Does everybody understand what I just did? I took the point in the shaded region and I'm plugging it in. So the question is -4 less than -1? Is that a true statement? Is -4 less than -1? Yes, as the negatives, if I go more negative, the lesser in value that number is. -4 is less than -1. That is true. If I picked a point, let's say I picked the point 0, 0. Now, it's kind of hard to see, but 0, 0 does not fall in that shaded area. So let's see if 0, 0 works. So I have 0 is less than -3/5 times 0 minus 1. Is 0 less than -1? No, 0 is actually greater than -1 because it's further to the right. So this is not true, which is why that point is not in the shaded region. The shaded region is where you can find your solution points. Has everybody got that? Yes? All right, so let's try another. All right, so the first thing I want you to tell me is if I'm looking at this inequality, what does this inequality tell me to do? I need to know shading and I need to know the type of line. What type of inequality do I have here? Okay, so I heard less than or equal to. So what does less than or equal to mean? What? Okay, so it means we're going to shade below, but this time my line is going to be solid because it's equal to. All right, so how am I going to plot this point? Anybody? How are we going to plot? How are we going to plot, not plot the point, how are we going to plot this line? What do we need to do first? Okay. So we're going to plot our y-intercept at -1. And then what are we going to do?
Then you're going to find the slope.
Okay, so what is my slope?
5/6.
And what is 5/6 telling me to do? All right, so up 5, right 6, because they're both positive. So from that point, I'm going to go up 5. So I'm going up 5. And I'm going to go right 6. And there's my new point. All right, so this time it's a solid line, so I can just draw a solid line all the way through. And you told me for shading, what type of shading am I going to do? Below. So remember what I said. I like to draw my little arrows. I go to the line and I draw arrows down so I know exactly which area is below. Questions about that one? We feel okay? All right, now let's switch it up a little bit. What am I going to do for this problem? All right, so here's my question. Can I graph it like this?
Yeah. No. Well, yeah.
Why not? Or what do I need to do?
They gotta add one.
Okay, so add a 1 where?
You gotta try. Well, you gotta try to find what is y great, well, less than or equal to the equation.
Okay, so this problem is not in slope-intercept form. So we can't plot the y-intercept and do rise over run because we don't know what the slope is. So in order to do this problem, you're going to have to solve for y. Okay? So that means that we're going to get y by itself. So we're going to get this y right here by itself. So my first step to do that is I'm going to move this x. So I'm going to subtract x. Now, the most common mistake the students make is they forget to bring down that minus y. So this is minus y is less than negative x plus 6. I always like to put my variable first because the variable comes first when you're doing slope-intercept form. Okay? Now what? Is y by itself? I'm asking, is y by itself?
No.
Okay, what is with the y that makes it not be by itself? There's a negative in front. For y to be by itself, it can have nothing else. Coefficient, negative, nothing like that. So how are we going to get the y by itself? What are we going to do with that negative? All right, well, let me ask you this. What is technically with that negative? What's with the y and the negative that is not there that we know is there? A 1. So if this is a 1, that's a negative 1. How are we going to get y by itself?
Well, you gotta divide it out.
We need to divide, just like if we had any other number in front of the y value, right?
Mm-hmm.
So what happens when we divide by a negative number with inequalities?
Oh, you just flip.
We flip that sign. So it's no longer less than or equal to, it's now going to be greater than or equal to. Remember, when we divide by a negative, we flip the sign, okay? And the last thing that we need to do to solve for this is we're going to have to simplify. All right, so what's in front of that x? A negative 1. So negative 1 divided by negative, hold on, let me get my little pointer. Negative 1 divided by negative 1 is what? Positive 1. So this is going to be positive 1x. And then we have 6 divided by negative 1. So 6 divided by negative 1, what is that going to equal? So minus 6. Now, I'm going to say this, not to discourage you, but to let you know, like, you've got to be able to solve for y. Regardless if it's an inequality, if it is just an equation, solving for y.
Purpose interruption to your first period class. Please release all ninth graders, last name A through J. Please release all ninth graders, last name A through J to the auditorium. Thank you.
All right, can y'all pause for just a second? Let me finish this problem, and I promise you can go, okay? So, greater than. What type of shading am I going to do for greater than? Huh? Above. Is this going to be solid or dashed? Okay. So we're going to plot our y-intercept. Our y-intercept is at -6. So we're going to go to -6. Let me make this a little bit bigger. All right, so -6. And then my slope is 1. What does the slope of 1 tell me? Okay, you have to have a fraction. So we're going to put it over 1. So this is going to be up 1, right 1. So up 1, right 1, up 1, right 1. So you told me it was solid. And you told me that it's going to be shaded above. So I'm going to draw my arrows above. And there's my solution area. Okay. All right, y'all go ahead. All right, so we have -4x plus 3y is less than -12. That's kind of hard to see. Can y'all see that okay?
Yeah.
Okay, so what do we need to do first in order to graph this?
Find the y-intercept. Or, is it where you combine that term?
Okay, so we're not necessarily going to combine like terms, but we're going to do those inverse operations in order to solve for y, right? Because in order to graph this, we need to solve for y. So what do I need to do first in order to solve for y here?
Oh, you got to add that 4x.
Okay, so I'm going to add my 4x to the right-hand side. So I have 3y is less than 4x minus 12. Again, I like to put my variable first on the right-hand side. Anybody have any questions about what I just wrote? We okay? All right, so what's the next thing we need to do to solve for y? Okay, so I'm going to divide by 3. Do I need to flip the sign for this problem?
No.
Why?
You're not dividing
I didn't divide by negative, so I don't need to flip the sign. The only time you flip the sign is if the number, the coefficient you're dividing by is negative. Now, I do need to simplify though. So I need to divide 4 by 3 and -12 by 3. All right, so 4 divided by 3, we're going to leave it as a fraction. We're going to leave it as 4 over 3x. Why do I want to leave it as a fraction? Well, if you're going to do the slope, you want to have a rise and a run. All right, then -12 divided by 3. What's -12 divided by 3?
-4.
Okay, so -4. All right, so what does this inequality sign tell me? Well, first of all, what is this inequality sign? Less than. So less than, what type of shading are we going to do with less than? So we're going to shade below. Is it going to be a solid or a dashed line? Okay. All right, and then from there, we're just going to plot our points. We're going to plot our y-intercept at -4. So we're going to go to -4. And then we're going to do our slope. Our slope is 4 over 3. So that's going to tell me to go up 4, right 3. So we're going to go up 4 and right 3. So you told me dashed. and shading below. So I'm going to draw my arrows here. So I'm going to show my arrows are pointing downward. And this is my shaded region. Okay? Does this help clarify a little bit? Now, make sure that for your Delta Math, the one from yesterday, if you did not show your work, you need to go back and show your work. I think some of you may have been trying to guess your way through it. Make sure that you go show your work because you're going to have to solve for y, okay? So if it's already solved for, then yes, you're going to graph it. That's not an issue. But if you have to solve for y, you need to show that work in order to submit it. Today, you have more inequality problems. They're just a little bit different, more graphs, that kind of stuff. And then there's a Canvas assignment. Now that Canvas assignment, it is, I think there's 2 attempts, if I'm not mistaken. So make sure that you look at the feedback for the attempts, okay? All right.